Okay, this is my third time trying to get through this in 15 minutes, so we're going to go fast. Radians is where we left off on March 12th. We decided that there was a relationship between the radius and the angle measures all the way around. And what that relationship was that if we think about this radius as a length that would trace out an angle measure, we decided we're going to call that 1 radian. That means all the way around we end up with 6.28 radians, which is a number that's referred to as tau, but tau is just 2 pi. So there are 2 pi radians in a circle. So where we were is, I'm just going to run through this really quickly. We decided that if this is the length of 1 radian, here we are at 1, here we are at 2, here we're at 3, here we're at 4, here 5, and here 6. So if this whole thing is 2 pi, that means at half a circle, we're at pi. And at a quarter circle, we're at pi over 2. And at 3/4 of a circle, we're at 3 pi over 2. These numbers are to give you a sense of exactly where you are in the circle. Pi is a number, as hopefully we know. It's 3.14 forever. So this number that's pi over 2 is around 1.57. You want to recognize that. It's a number you want to kind of have in your head. And this 3 pi over 2 is 4.71. So now we have 2 units of measures for a circle. It's just like, centimeters and inches. It's just like kilograms and pounds. They're just 2 different measures. But radians are really special because they are actually intrinsic to a circle. There's nothing that you would see as a brilliant Neanderthal and say, oh, circles, 360. But this idea of its proportion to its radius hopefully makes sense. So how many degrees are in 1 radian? Well, let's see. How many degrees are in 1 circle? There's 360, and there's 2 pi radians in a circle. So that means there's 180 over pi in 1 radian. And just to save us time, that's around 57 degrees. That also yields conversion factors for us. If we have degrees, we have theta degrees, and we want to turn it into radians, we're going to multiply by something that gets rid of the degrees. And so the proportion is pi over 180. That's our conversion factor. If we've got a theta that's in radians and we want to go to degrees, we can multiply it by 180 degrees over pi. Conversion factors. Just something that is in essence 1, a 1-to-1 relationship. So if we're going to convert these things, all we need to do is say things like convert 20 into radians. We're going to say 20 times, we want to get rid of the degrees, so 180 pi, that's pi over 9. I'm going to tell you I'm going to run out of time, so I'm going to leave these for us to maybe do in class or for you to do on your own. There's also practice on Khan Academy with this. If we want to change to degrees, we're going to take 11 over 12 pi times 180 over pi. Let's see, 12, 6 goes in there 30 times, and we're left with 2, so 15. The pi's cancel, so we're left with 11 times 15. Oh, that's 10 times 15 plus an extra 15. It's 165 degrees. I'll leave these 2 for us to do later, and we're just going to jump to it. And let's look at, these are degree measures that you should sort of recognize. So if we convert 30 degrees into radians, we're at 30 times pi over 180. We're at pi over 6. I'm going to leave the work for us to either do in class or you to do on your own, but I'm just going to say trust me on this. This turns into 5 pi over 6. This turns into 7 pi over 6. And this turns into 11 pi over 6. Excuse me. 60 degrees, pi over 180. That's going to be pi over 3. This is going to be 2 pi over 3, 4 pi over 3, and 5 pi over 3. What do we notice about this? Look at this. So it looks to me that reference angles equal to 30 degrees yield n pi over 6 pieces. This shows you that those are irreducible pieces of 6. Then, what happens here? Oh, it looks to me we have another pattern. It looks like reference angles equal to 60 degrees yield n pi over 3 pieces. All of these are in reduced form, and they all have a denominator of 3. 45s. We're at 45 times pi over 180. Oh, that's 4 pi over 4. This is going to be 3 pi over 4, 5 pi over 4, and, oops, 5, I'm sorry, I can't count, 7 pi over 4. Oh, let's take a look at these guys. Look at that. They're all 4s. Reference angles equal to 45 are going to yield n pi over 4 pieces. The ones down here are kind of nice. They're sort of special because 90 degrees is halfway towards pi, so it's pi over 2. Here's all the way to pi. Here's 3 pi over 2, and here's 2 pi. I don't know that we need a pattern for these as much. You're going to kind of see a different pattern that occurs. But these all happen, these angle measures all happen on an axis. So that makes them kind of understandable angle measures in a lot of different ways. So we don't need to look for as many patterns with those. Okay, let's see what kind of patterns we get. Here's our 30-degree measures, which are now pi over 6 pieces. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Here's our 30-degree angle measures. So here we're at pi over 3, 2 pi over 3, 5 pi over 3. Oop, I'm sorry. I think I just did that exact same one again. 4 pi over 3, and 5 pi over 3. Our 45s, oh, I want a highlighter instead. Colors are all looking the same. The notes are better for you. I think I messed up one of these colors. Here we're at 45s. Here we're at pi. Whoop. Here we're at pi over 4. Here we're at 3 pi over 4. 5 pi over 4. 7 pi over 4. And our last ones are on the axes. And on my first 2 attempts, I tried to talk fast enough to get in why these are irreducible, but we can either talk about it in class or probably just skip it. Here we're either at 0 or 2 pi. Here we're at pi over 2. Here we're at pi. And here we're at 3 pi over 2. So let's see if we see any patterns. Does this yellow one even show? Maybe it does. So what are the patterns that are going on here? Notice in this first quadrant, the numerators are all just pi. So obviously the bigger the denominator, the smaller the angle measure. So we go 6, 4, 3, 2. Over here, what's happening over here? Let's see, 2 and 3. See, it even holds for this one. But here we are, 2 and 3, 3 and 4, 5 and 6. Well, pi's kind of special. But it looks to me like our numerator is equal to the denominator minus 1. So as long as you get the 6's and the 3's and the 4's in the right place, oh, you're just taking the denominator minus 1. What's happening down here? Oh, here it looks like the numerator is equal to the denominator plus 1. 3, 2, 4, 3, 5, 4, 7, 6. And our last quadrant, it looks like, let's see, 11 and 6, 7 and 4, 5 and 3. It looks to me that the numerator is equal to, and we don't need these parens here because of order of operations, but just to make sure, it's 2 times the denominator minus 1. Oh, 2 times 6 is 12, 11. 2 times 4 is 8, 7. 2 times 3 is 6, minus 1 is 5. So I know that's a pretty fast version, but we're going to spend 2 days just kind of getting our heads around this and practicing exact values for degrees. So lots of Kahoots in the next 2 lessons. I hope they're fun. So please come to the Zoom class if you can. The more people that participate in the Kahoots, the more fun it is. I didn't tell the B block class this, but I did go on Amazon and ordered organic suckers again. Unfortunately, I might be sending them to you in the mail, but we will have some prizes for the best Kahoots and try to get a nice friendly competition going. So take care. See you hopefully tomorrow in class, and have a good night.